Beneath the sunlit waves, beyond the reach of ordinary exploration, lies a world that challenges everything we know about life on Earth. It is a realm of perpetual darkness, crushing pressure, and icy temperatures, a place so hostile that, at first glance, it seems inhospitable to all but the most resilient forms of life. And yet, in these depths, life not only persists, it thrives. Here, in the abyssal plains and trenches that stretch for thousands of miles, the phenomenon of deep-sea gigantism unfolds, giving rise to creatures of a scale so vast, so improbable, that they defy the boundaries of our imagination and the limits of scientific explanation. Imagine drifting through this midnight world where the pressure is hundreds of times greater than at the surface, and the temperature barely rises above freezing. Instead of diminutive stunted forms, you encounter tube worms longer than baseball bats, their pale bodies undulating in unseen currents. Giant isopods, distant cousins of the common pillbug, scuttle across the ocean floor, their armored bodies as large as footballs. And lurking in the gloom, a colossal squid glides silently, its eyes as wide as dinner plates, its tentacles stretching meters into the void. These are not the monsters of myth. They are the very real denizens of our planet's last true wilderness. The phenomenon known as deep-sea gigantism presents a paradox. In the deep ocean, resources are scarce. Sunlight never penetrates, limiting the energy available for life. The pressure is immense, and the cold is relentless. Conventional wisdom would suggest that creatures living here should be small, conserving energy to survive in such a forbidding environment. And yet, the opposite is true. Some of the largest invertebrates on Earth inhabit these depths, growing to proportions that seem impossible. Scientists have spent decades peering into this mystery, deploying submersibles and remotely operated vehicles into the abyss, collecting specimens and data in a quest to unravel the enigma. Theories have emerged, each attempting to shed light on why the deep sea breeds giants. One hypothesis focuses on oxygen. In the cold, deep waters, oxygen dissolves more readily, potentially allowing for larger body sizes. Another theory considers the slow metabolism of deep-sea creatures. Their lives are measured in years, even decades, and their growth proceeds at a glacial pace. Some researchers point to the effects of pressure, suggesting that gigantism could be an adaptation to the immense forces pressing in from all sides. Yet, none of these explanations fully capture the complexity of the phenomenon. Each new discovery seems to raise more questions than answers. The deep sea is a place where evolution has taken unfamiliar paths, and where the rules appear to bend, if not break, under the weight of circumstance. Take, for example, the giant amphipod. In shallow waters, amphipods are tiny, almost invisible to the naked eye. But in the deep, some grow to the size of a human hand. Why does this happen? One idea is that larger body size is an advantage when it comes to moving through the thick, silty sediments of the deep sea, or when scavenging for scarce food sources. A giant amphipod can cover more ground, store more energy, and survive longer between meals. Or consider the Japanese spider crab, whose legs can span up to 4 meters. Its massive size is not just a curiosity, it may be a strategy for traversing the uneven terrain of the ocean floor, or for deterring predators in a world where every encounter could be fatal. Then there are the colossal squid, whose very existence was once doubted by science, relegated to the realm of sailors' tales and folklore. Today, we know they are real, creatures with eyes the size of soccer balls, adapted to detect the faintest traces of light and movement in the abyss. Their size may serve as a defense against the deep sea's apex predators, such as sperm whales, or as a means to capture rare, elusive prey. The mystery grows deeper when we examine the fossil record. Many of the deep sea's giants bear a striking resemblance to ancient marine creatures, suggesting that gigantism may be a relic of prehistoric times, a trait that has endured for millions of years in the planet's most stable environment. Unlike the surface, where ice ages and mass extinctions have reshaped life repeatedly, the deep ocean is a time capsule, a place where ancient lineages persist and evolutionary experiments continue uninterrupted. Yet, there is another layer to this enigma, one that touches upon the very nature of life itself. In the darkness of the abyss, far from the influence of sunlight and surface events, evolution follows its own trajectory. Here, survival depends on adaptation to extremes: pressure, cold, scarcity. Perhaps in this crucible, gigantism is not simply a quirk, but a fundamental response to the challenges of existence at the edge of possibility. Recent advances in technology have allowed scientists to probe these depths as never before. Autonomous vehicles and deep-diving robots return with footage of creatures so bizarre that they seem otherworldly. Each expedition uncovers new species, many of them giants, adding to the growing catalog of life forms that defy our expectations. Genetic studies reveal clues to their metabolism and growth, but also hint at unknown mechanisms, molecular pathways and developmental processes unique to the deep. What is clear is that deep-sea gigantism is not a uniform phenomenon. It varies from species to species, and from one region of the ocean to another. Some giants emerge in the abyssal plains, others in hydrothermal vent communities, and still others in the Hadal trenches, where the planet's crust bends and buckles under unimaginable weight. In each case, the giants are a testament to the resilience and adaptability of life, a reminder that the rules we take for granted may not apply in the world's last unexplored frontier. And so the mystery endures. Scientists continue to speculate, to hypothesize, to gather evidence, but the deep sea keeps its secrets well. For every answer, there are a dozen new questions. Why do some lineages grow large while others remain small? What triggers the development of giant forms? Is gigantism an advantage, a necessity, or merely a side effect of life at depth? As our ability to explore these realms improves, so too does our appreciation for the strangeness and wonder of the ocean's depths. Each new discovery challenges our understanding, forcing us to reconsider what is possible. The giants of the deep are not just anomalies. They are living proof that life, in all its forms, is more varied, more adaptable, and more mysterious than we can imagine. In the end, deep-sea gigantism remains one of marine biology's greatest unsolved puzzles. It is a phenomenon that beckons us to look deeper, to question more, and to embrace the unknown. The ocean's giants are ambassadors from a world beyond our sight, a world where the impossible becomes reality, and where the boundaries of life are tested and redefined. As we continue our journey into the abyss, one thing is certain: the ocean is Earth's last true wilderness. Every dive, every discovery reveals a realm stranger than fiction, a place where the ordinary laws of nature are rewritten by the forces of darkness, depth, and time. In this world, the giants reign, not as monsters, but as marvels, and their presence challenges us to rethink not only our science, but our sense of wonder. Deep-sea gigantism is more than just a biological curiosity. It is a testament to the power and mystery of evolution, a reminder that even in the most extreme environments, life finds a way. The quest to understand why the deep breeds giants is ongoing, a journey into the heart of the unknown, where every answer opens the door to new questions, and where the greatest secrets still lie hidden in the darkness, waiting to be revealed.